Ever wonder how those bright streetlights or stadium lights work? A lot of the magic comes from something called high intensity discharge lamps or HID lamps. And at the heart of these is a very important part called the arc tube. Today, we're going to break down how arc tubes work, specifically in mercury vapor, metal halide, and high pressure sodium lamps, without any jargon or tech talk. Just plain, easy to follow info. Let's dive in. Let's start with mercury vapor and metal halide lamps. Inside each of these lamps is a little tube called the arc tube that's made from quartz glass. Imagine a skinny glass capsule, kind of like a mini test tube. Now, this tube is short and wide, and here's why. It needs to have enough space inside for something called a starting electrode, a little helper that gets the light going when you flip on the switch. The tube is made from one solid piece of high-quality quartz, with both ends sealed up tight using intense heat. This seals in 3 little wires. 2 are the main electrodes and 1 is the starter. Now here comes the cool part. Before sealing it, manufacturers use a tiny glass straw to add gas and special metals into the tube. These metals are sometimes called amalgam. Once everything's inside, they heat the straw until it melts and seals shut, trapping the gas and metal inside like a time capsule. When you first turn on the lamp, it takes about 100 hours of use for the metals inside to settle in. After that, the lamp runs steadily with almost no change in voltage. Simple, stable, and long-lasting. Now, high-pressure sodium lamps, or HPS lamps, are a little different. Their arc tube is long and skinny, like a pencil. But here's the twist. Instead of glass, they use a special ceramic called polycrystalline alumina, or PCA. Why? Because sodium, which is one of the ingredients inside, would actually damage regular glass. PCA is super tough and doesn't get eaten away by sodium. Because PCA can't be sealed by mounting like glass, manufacturers glue the end caps to each end of the tube using high temperature adhesives. These caps hold the electrodes in place and seal everything up. Inside the tube, they add a mixture of sodium and mercury metals, plus a gas to get things started. But unlike other lamps we talked about, HPS lamps use extra metal, more than what gets vaporized during operation. This means the temperature inside the tube plays a huge role in how the lamp behaves. If it gets too hot, too much metal turns into vapor and the voltage goes up. If it gets too cold, not enough vapor forms and the lamp won't perform well. Back when these lamps first came out, the extra metal, called amalgam, was stored in a little reservoir outside the arc tube. But if the lamp got bumped, likely by wind or vibration, the metal could splash back and cool the arc tube suddenly. That could cause the lamp to blink off and restart. It was super annoying. Modern designs fix this by moving the reservoir inside the tube, making them much more stable. But here's one more thing you need to know. Over time, the voltage needed to run an HPS lamp slowly increases. about 1 to 2 volts for every 1000 hours it's used. Eventually, the lamp needs more voltage than the system can provide. When that happens, it starts cycling, turning on, then off, then on again. That's a sure sign the lamp has reached its end of life. Let's wrap it up with a quick memory trick. Think of quart arc tubes like sealed glass capsule. Great for mercury vapor and metal halide lamps. Think of HPS arc tubes as ceramic pencils, tough enough to hold sodium but sensitive to heat. If you ever see a streetlight flicker on and off like it's trying to decide if it's awake, it's probably an HPS lamp at the end of its life. And that's the story of arc tube design in HID lamps. Thanks for listening. I hope you feel a little more confident in understanding how some of the world's most powerful lamps actually work. For more helpful explainers, stay tuned or reach out with your questions. Until next time, stay curious.